So this is the first day of 4.6 and we're going to be working with complex numbers. And before we can get to complex numbers, we need to talk about imaginary numbers. So the way imaginary numbers came about is by taking the square root of a negative number. Before we couldn't do that, but now with imaginary numbers we can. So the square root of -1 is denoted by I. And that means that I squared would equal -1. So we can use the imaginary unit I to help us write the square roots of any negative number. So for example, if we had the square root of -3, we would write that as I times the square root of 3, right? Because I was the square root of -1, so it'd be the square root of -1 times the square root of 3. And we know that from the section before, using our multiplication property, this would be the -3 in the radicand. So property 1 is just generalizing that by saying that if we have the square root of a negative number, then we can write that as I times the square root of the positive number. And what property number 2 is saying, if I have I times the square root of 4, and I square that, then I'll get I squared times 4. And we know that I squared equals -1, so I'll have -1 times 4, which equals -4. So I went from here to here. And if you think about it, property 2 is kind of the reverse of property 1. Because if I had the square root of -4, then by property 1 that equals I times the square root of 4. And so by property 2 it says if I square this, then I square the other side, then I'll get -4. Now let's try using what we know about imaginary unit I to help us solve this. So I have 2x squared plus 11 equals -37. So if I'm solving for x, I need to isolate it. That means -11 and then divide by 2. And now I'm ready to take the square root of both sides. So I'll have x squared equal to plus or minus x equal to plus or minus the square root of -24. Now I need to write this in terms of I. So that would just be plus or minus I square root of 24. And now I need to simplify my radical, so I'll get x equals plus or minus I times square root of 4 times the square root of 6, which equals plus or minus I times 2 times square root of 6. And we always write the number before I, so it needs to be 2I times the square root of 6. So those are my two solutions to that quadratic equation. And solving for x squared equals -13 here, I could go ahead and take the square root right off the bat. So I'll get x equal to plus or minus the square root of 13, -13. Need to write it in terms of I, plus or minus I square roots of 13. This is by property 1. And I can't rationalize that radical anymore, so that's my final answer. I get positive I square roots of 13 and negative I square roots of 13. There's two examples here that I would like you to try on your own, so pause the video and good luck. Okay, so you should have gotten two solutions to each of the problems, and they are listed above. So you'll need to know the standard form of a complex number, and that is a plus bi. So a and b are just any real number, and a is the real part of the complex number and bi is the imaginary part. So a complex number has two parts. It has a real part and an imaginary part. Basically what this diagram is showing you is that we've been dealing with complex numbers this whole time, but our imaginary part was always 0. So that left us with the real number of 5. Now we're going to be working with an imaginary part that is not 0, so b could be anything. However, if a equals 0, or the real part equals 0, then we have what's called a pure imaginary number. So we only have the imaginary part left. And we can add and subtract complex numbers as long as we add or subtract the real parts and the imaginary parts separately. So we have the sum of complex numbers. So if I had 7 plus 2i plus 3 minus 4i, I can add my real numbers. So I'd have 7 plus 3. And then I would have 2i plus my negative 4i. And technically this would be 2 minus 4i, just to be precise. So now I would get 10 plus negative 2i, which is 10 minus 2i. And now I'm in standard form. So subtracting complex numbers is going to be the same way. However, we need to pay attention to our signs. So looking at the same example, except I want to subtract them. So I would take my real numbers and subtract them, and then I would add it to the difference of my imaginary numbers. So I would have 4 plus 6i as my final answer in standard form. So I would like you to try this example on your own and write this in standard form. And you should have gotten 13 plus 3i. So I would like you to try this example on your own as well. So pause the video. So you should have gotten 4 minus 3i, or you may have written it as 4 plus a negative 3i. And we do multiplication the same way as we would FOIL, like a quadratic or something like that. So I'm going to distribute. So then I would have negative 24i plus 4i squared. But this isn't simplified, so I need to make sure that I write this as negative 24i plus 4 times negative 1, because I squared was negative 1. And so now this becomes negative 4 minus 24i, because in standard form our real part has to come first and then the imaginary part. So I would like you to try this next one and use the FOIL method to put this in standard form. And you should have gotten negative 22 plus 71i as your final answer. So that's the end of day 1. Day 2, we're going to be talking about complex conjugates and the complex plane, and also absolute value of complex numbers.